Welcome to Automatarium, the next-gen platform revolutionizing the way we explore formal languages and automata theory. Step into a modern, intuitive experience designed to empower your learning journey. Let's embark on a voyage into the core features and the magic behind Automatarium. This tutorial will guide you through the process of constructing Turing machines. A Turing machine can represent recursively enumerable languages, but also has vast computational potential. It consists of a head which scans and modifies an input tape. As it encounters a symbol on the tape, it can replace it, shift its internal mode, and then move either left or right. In this tutorial, we'll construct a Turing machine that increments a given binary number. Navigate to the Automatarium webpage and click Start Building. From the provided choices, opt to create a new Turing machine. Using the state tools in the left-hand toolbar, add 3 states onto the canvas. Access the State menu by right-clicking a chosen state. Designate Q0 as the initial state and Q2 as the final state. We'll create 2 self-loop transitions at Q0. You can create a self-loop by simply clicking the state while the transition tool is selected. The Turing machine input dialog takes 3 values. First, the character it reads on the head of the tape. Second, the character to replace the first value with. Third, the direction the head of the Turing machine will move to after processing this step. The direction value can be R, L, or S, which represent moving the head 1 position to the right, moving the head 1 position to the left, and staying in the same position. Our initial move is towards the tape's end. Irrespective of encountering a 0 or 1, let it remain as it is until the tape's end is reached. So, in state Q0, we'll create a few transitions. If the head reads 0, write 0 and move right. If the head reads 1, write 1 and move right. We should stop moving to the right when we reach the end of the input. In Automatarium, lambda represents the empty string. We'll add a transition between Q0 and Q1 with a read value of lambda, a write value of lambda, and left as the direction to move. This will position the head on the last character of the input string. We now need to replace all trailing ones with zeros. To do this, we can create a self-loop on state Q1. If we read 1, we should write 0 and move to the left. Then, once any trailing ones have been replaced with 0, we should replace the next 0 or blank we encounter with 1. We'll need to add 2 transitions between Q1 and Q2. For the first, if we read blank, we'll write 1 and move right. For the second, if we read 0, we'll write 1 and move right. Let's test our machine. Click the flask icon located on the right-hand toolbar or use Shift-1 to access the testing lab. Type 101 into the trace field and progress through the input sequence using the directional buttons. Observe the Turing machine tape visualization at the bottom of the screen. It progresses to the input's end, turns around and changes the final one to 0. It then reads the 0 to the left and replaces it with 1. We can see 101 becomes 110. Let's try a different input. This time 1111. Stepping through, we can see that all of the trailing ones are replaced by zeros, and the start of the tape has 1 added to it. Our machine works as expected. For a detailed overview of your Turing machine, use the shortcut Shift-3 or click the Info tab in the right-hand toolbar. Here you can find the alphabet, state transition table, and transition function. Want to share your creation? Go to File, then Export. You have the options of exporting as an image, JSON file, or URL. With the close of this tutorial, your journey into the world of Automatarium is just beginning. Embrace the tools, the features, and the intuitive design that awaits you. Remember, every challenge in understanding is an opportunity for growth, and Automatarium is here to guide you through it. For more information, our contact details and a link to our GitHub repository can be found in the video description below.